Last time we were solving equations by factoring. So we could have solved this equation, x squared minus 16 equals 0, by factoring. And today we're going to use a different method called the square root method to solve a similar equation. So if we were to solve this by factoring, we would get it equal to 0, which it already is, and then look for a greatest common factor, which is 1. So that's not going to change our problem. And then we would look at the structure of the problem. I have two terms, and they are subtracted. Both are perfect squares, so this actually factors by difference of squares into x plus 4 times x minus 4 equals 0. And then we applied a property that said if I have two things multiplied by each other equaling 0, then at least one of them had to be 0 to start with. That is called the zero product property. So we would use the zero product property to rewrite x plus 4 times x minus 4 equals 0 into two equations, x plus 4 equals 0 or x minus 4 equals 0. And then solve those two equations. So minus 4, we get x equals negative 4 or plus 4, x equals positive 4. Using the square root method, the process is a little different, but we will still get the same answer. So we'll start with x squared minus 16 equals 0. And we're going to go through one problem, and then we will write out the method step by step. The first thing that we're going to do in the square root method is we are going to isolate the squared thing. So in this case, the squared thing is x squared. So we want to isolate x squared. And we do that by adding the 16 to both sides. So we get x squared equals 16. After we've isolated that, we're going to go ahead and take the square root of x squared and the square root of 16. We can do that as long as we're taking the square root of both sides. So when we take the square root of x squared, is just x, and when we take the square root of 16, you'll probably tell me that the square root of 16 is 4, which is true. However, there is another number that when multiplied by itself gives you 16, and that is negative 4. So x will equal plus or minus 4. And that's how we get those two solutions. X equals plus or minus 4. Now you may not have known before when you should answer plus and minus 4 and when you should just say it equals 4 when you're taking square roots. Well, here's the key to that. That is, if you have to draw in the radical symbol for a problem, your answer must include the plus minus symbol. So in this problem, it started out with x squared minus 16 equals 0, and we were the ones who drew in that radical right on this step, so we have to include the plus minus in our answer. Okay, let's look at those steps, and then we'll work some examples also. So steps to solve using the square root method. The first step we said was to isolate the squared thing. This is not a mathematical term. So isolate the squared thing. You'll know the squared thing because it will have an exponent of 2 attached to it. Sometimes it's just like an x squared or a q squared or a whatever letter squared, and sometimes it's a parenthesis squared. So you'll just have to pay attention to what has that squared exponent attached to it. The second thing you're going to do is take the square root of both sides. Of the equation. And I want you to write this really big because I don't want you to forget. When you take the square root of both sides, I want you to remember to use what symbol when we take the square root of both sides. The symbol we have to remember to use is the plus and minus symbol in front of that number. So remember to use the plus minus. And then the third step is sometimes you're still going to have to do some solving to get x by itself. That's not always going to happen, but you should remember that sometimes you still have to solve to get x equals by itself. Let's look at a couple of pretty straightforward examples, and then we'll get into some that are a little bit more complicated. Okay, keep those three steps in mind. Isolate the squared thing, take the square root of both sides, remember to use the plus minus, and then that third step, sometimes we still have to do some solving. So here's one example that's real similar to the first one we did, and then one that will have a little bit more work involved. So x squared minus 121 equals 0. We need to isolate the squared thing. This time the squared thing is x squared again, so we'll add that 121. So we get x squared equals 121. Now that the squared thing is isolated, we'll go ahead and take the square root of both sides. The square root of x squared is x, and the square root of 121 is plus or minus 11. So that is actually two answers, x equals 11 and x equals negative 11, but it's acceptable to write plus and minus 11. On the next example, you'll notice that when you add your 75 to both sides, so you get x squared equals 75. It's the same steps we've had, but when we take the square root of 75, 75 is not a perfect square. That's okay. What we're going to do is simplify that radical. So we'll have to split 75 into its factors. Let's see, 75 can be 3 times 25. The 3 doesn't break down any further, but the 25 can break down into 5 times 5. So remember, in square roots, we bring outside in front of the radical any pairs, so the two 5s will come out and turn into one single 5, and that 3 will be stuck inside the radical. So I will have 5 times the square root of 3, and I have to remember to put my plus and minus symbol out in front. So it is plus or minus 5 times the square root of 3. So positive 5 radical 3 and negative 5 radical 3 are the two solutions to that equation. Let's get into some more detail with examples. Let's see. How about 3x squared plus 24 equals 0? We still need to isolate the squared thing. You can see that this time the squared thing is still an x squared, but it has a times 3 out in front of it. So we need to subtract over our 24. So we get 3x squared equals negative 24. But the squared thing is not isolated yet because it's 3 times. So I need to divide both sides by 3. And that gives me x squared equals negative 8. So the squared thing is isolated at this point. I'm going to go ahead and take the square root of both sides. You notice that I'm now taking the square root of a negative number. So when I simplify that radical, my answer is going to include an I. That 8 breaks down into 2 times 4. The 2 doesn't break any further, but the 4 breaks into a 2 and a 2. So I can bring out a pair of 2's, so I'll have a 2 out in front. This other 2 has to stay in, square root of 2. And remember, this negative comes out and turns into an I. And that belongs between the coefficient and the radical. So 2i times the square root of 2. On the left side, square root of x squared is x. So x equals plus or minus 2i times the square root of 2. Here's one that's a little bit more involved yet. So x minus 5 squared equals 81. This time your squared thing is not just an x squared, it is x minus 5 squared. So this whole side has my squared thing, and it's already isolated. So I can go ahead and take the square root of both sides. And on the left side, I've got the square root of x minus 5 squared, which gives me x minus 5 equals, on the right side, the square root of 81 is going to give me plus or minus 9. Now this is where I was telling you, you sometimes still have to do some work to solve for x. So I still am going to have to add 5 to both sides. On the right side, the space you want to put that plus 5 in is before the plus or minus sign. So we want to always put our plus 5, or whatever it is we're adding or subtracting, in front of the plus or minus. So that will give me x equals 5 plus or minus 9. Now we're still not done with this problem, because 5 plus or minus 9 really means x equals 5 plus 9 or x equals 5 minus 9. And we have to work out both of those situations to get the answers for x. So on 5 plus 9, x will equal 14. And then on 5 minus 9, x will equal negative 4. So the two solutions to this equation are x equals 14 or x equals negative 4. Let's do a couple more that are complicated like that. How about negative 2 times x plus 7 squared equals 72. The squared thing this time is that parenthesis x plus 7. So we'll want to isolate the x plus 7 squared. We'll divide both sides by negative 2. Divide by negative 2. Now that's going to cancel this negative 2 and that negative 2, so I'm left with x plus 7 squared equals, and then 72 divided by negative 2 is negative 36. Now the squared thing is isolated, so I can go ahead and take the square root of both sides. Square root, and that gives me x plus 7 equals the square root of negative 36. The negative, remember, turns into an I. 36 is a perfect square, and that is 6. So the square root of negative 36 is 6i. Do not forget your plus and minus out in front. I'm still not finished because I have not solved for x. So we need to subtract the 7 from both sides. And do you remember where that minus 7 goes when you have a plus or minus? It's going to go in front of the plus or minus. So it's going to be negative 7 plus or minus 6i. So x will equal negative 7 plus or minus 6i. Now remember that that answer really means x equals negative 7 plus 6i and x equals negative 7 minus 6i. Notice that these two solutions are the complex conjugates of each other. So we know that we have two solutions, but we are allowed to give our answer as negative 7 plus or minus 6i. We just have to remember that that really means two different solutions, and they are actually two different solutions that are complex conjugates of each other. And that will happen every time you have a solution to an equation that has complex numbers in it. There will always be two if they're complex, and they will always be complex conjugates. Let's look at another one. 3x minus 5 squared equals 50. The squared thing in this problem is that whole parenthesis, 3x minus 5. So it is already isolated. So I'm ready at this point to take the square root of both sides. Square root, square root. So the square root of the left side will be 3x minus 5. And the right side, 50 is not a perfect square, but it will break up into 10 times 5. Let's see, 10 breaks into 2 times 5. 5 doesn't break up any further. But I do have a pair of 5s with a 2 left in. So this will be 5 square roots of 2 with a plus and minus out in front. I still have to solve for x. It's not done yet. So I'm going to start solving for x here by adding 5 to both sides. Remember that that 5 is going to go before the plus and minus symbol. So I'll have 3x equals 5 plus or minus 5 times the square root of 2. I've still got to solve for this x. I have 3 times x equals this 5 plus 5 square roots of 2. So to solve for x, I need to divide both sides by 3. So divide by 3. The 3x divided by 3 just leaves me with x, and that equals 5 plus or minus 5 square roots of 2, all divided by 3. Now I do want to stop and talk about how to simplify something like this. Now this does actually mean two different solutions, 5 plus 5 square roots of 2 all over 3 and 5 minus 5 square roots of 2 all over 3. But since I can't combine 5 and 5 square roots of 2 because they're not like terms, that's as simple as the numerator gets. I want you to notice though that I could simplify the coefficients, but only if all 3 coefficients, this 5 here, and this 3 here, could be simplified by a common factor. So I'm going to just write a note that this could be simplified only if all 3 integers have a common factor. So if I could divide this integer, and this integer all by the same factor, then I should do that, and that would simplify that problem, that answer. But I can't, so this is actually the answer in its simplified form. Let's see what other examples we can come up with here. How about 3 times x plus 4 squared equals 18? So you want to ask yourself, what is the squared thing? The squared thing is x plus 4. And is it isolated? No, because it's times 3. So I'll need to get it by itself by dividing both sides by 3. That gives me x plus 4 squared equals 6. And now the squared thing is isolated, so I can take the square root of both sides. That gives me x plus 4 on the left equals 6 can only break into 2 times 3. Neither of those is a perfect square, so it's just going to be left plus or minus square root of 6. And in order to isolate that x, I still need to subtract 4 from both sides. Remember that subtracting 4 goes in front of the plus or minus symbol, so that this solution will be written x equals negative 4 plus or minus the square root of 6. That is as simple as that solution gets, but I want you to notice the same thing that we had with our complex solutions from this other example, is that this really means two solutions, negative 4 plus the square root of 6 and negative 4 minus the square root of 6, which are conjugates again. So there are a couple of times that our answers will contain conjugates. One is when we have a complex solution. The other is when we have an irrational solution. And this is going to become an important concept as we get further into solving these equations. I think we should solve a couple with fractions, because fractions can be a little bit frightening at first if you're not sure how to deal with them. And there are a few different scenarios that fractions creep up, and we deal with each one slightly differently. So we've got 49x squared equals 81 will be our first fraction example, and then 25x squared equals 18. The differences between these two problems, in the first problem I've given you, the coefficient on the x squared is a perfect square and the constant term is a perfect square. In the second example, the coefficient is a perfect square, but the constant term is not. We're still going to follow our same steps, so I need to isolate my squared thing. In this case, my squared thing is x squared. So let's go ahead and divide both sides by 49, which gives me x squared equals 81 over 49. Now that the squared thing is isolated, I can go ahead and take the square root of both sides. And the square root of x squared is easy, that's just x. But the square root of 81 over 49 can be a little bit funny looking, but you can think of it as the square root of 81 over the square root of 49. And then since those are both perfect squares, it just simplifies pretty easily into 9 and 7. But what is the thing that we have to remember when we're solving these problems where we have the radical that we draw in? So we have to remember to use our plus minus. So this equation will have two solutions, x equals positive 9/7, x equals negative 9/7. So we can leave that as plus or minus 9/7. Well, let's see how the problem is different when one of our terms is not a perfect square. So we'll still divide both sides by 25. We get x squared equals 18 over 25. Now when we take the square root of both sides, square root, we get x equals, we got to remember our plus minus. Now if we split the numerator and denominator again, we can see the denominator is nice, it comes out to be 5, but the 18 does not. So we're going to have to break the 18 up into maybe 3 times 6, and then the 6 continues, so the 3 does not break up, but the 6 breaks into 3 times 2. So I have a pair of 3's that comes out, and the 2 stays in. That gives me 3 square root of 2. So I have plus or minus 3 times the square root of 2 over 5. And that cannot be simplified any further. Got one more fraction problem for you, and then we'll be done. 3x squared equals 625. The squared thing is just x squared again, so we'll divide both sides by 3. We get x squared equals, x squared equals 625 over 3. Now 625 is not divisible by 3, so I cannot simplify that fraction. What I can do is go ahead and take the square root of both sides. Square root of x squared just leaves me with x. So x equals, remember the plus and minus, the square root of 625 actually comes out to be 25. But the square root of 3 does not simplify. So I'm going to need to do something called rationalize the denominator. And in order to rationalize the denominator, we need to multiply by the square root of 3 over the square root of 3. So we'll have x equals plus or minus 25 times the square root of 3 stays 25 times the square root of 3, but the square root of 3 times the square root of 3 just becomes regular 3. So we have plus or minus 25 square roots of 3 over regular 3. We do want to check to see if the 25 and the 3 can simplify, but it cannot, so this problem is as simple as it's going to get, and that is our two solutions.